the Mathematics Class 11, Chapter 8, Sequences and Series. So we have seen what are sequences, how we can find different terms of a sequence. We have also seen how we can find the sum of the terms of the sequences. Okay, so they are called corresponding series. We saw different types of sequences. We saw arithmetic progression and we saw geometric progression. And we also saw how you can find geometric mean and what are the differences between geometric mean, arithmetic mean, as well as we had solved one sum where we had also introduced the harmonic mean. So these were the basic concepts that we dealt with when we were, trying to see what are sequences and series and trying to solve the related examples. So today we will move on with a few more examples so that you can get the application of the concepts and application of the formulae that we have seen till now. Okay, so we will start now. Okay. So suppose the question is, when the method length between 15 and minus 30. Okay, so we have been asked that there are two numbers, 15 and minus 13, and we have to introduce six terms between these, and these six terms are actually your arithmetic means. Okay, so let the required terms be A1, A2, A3, A4, A5, and A6. Okay. Such that the will become 15, A1, A2, A3, A4, A5, A6, and minus 13. Okay, becomes this is what AP. Okay, because we are dealing with arithmetic means, we are going to call this an AP. Now we know that the common difference D is going to be equal to, if we have suppose only the first and the last term. Okay, this can be found as B minus A. Okay, so suppose your A is equals to 15 and B is equals to minus 13. Okay, divided by n plus 1. Okay, so that's what then becomes minus 13 minus 15. One, you have the n terms. Okay, so the arithmetic means of the n we are considering as your number of arithmetic means. Okay, so 6. So 6 plus 1 is 7. So this is minus 28 by 7, and this is minus 4. Okay, so we now know our common difference. Now we can easily find all of the arithmetic means. Okay, arithmetic mean, we are calling it arithmetic mean, but you don't have to solve it with the arithmetic mean concept. You can, once you find your D, and we already know our first term A, we can easily use the formula for the general term of the of the arithmetic progression. Okay, So A1 will actually be A plus n minus 1 B. Okay. So this is your not your A1, sorry, your this is your general term. Okay, usually this is how we do. So now what you will have is your A1 is actually going to be your A2. Okay, so that means it is A plus, so I will substitute the term for A. So 15 plus your n is 2 over here, so 2 minus 1 and your d is minus 4. Okay, so this eventually then becomes 15 plus minus 4. Okay, and this is 11. Now similarly A2, okay, so this will actually then become 15 plus n minus 1. Okay, so this is your A3. So n minus 1, 2 minus 1 is 2. So 2 into minus 4. So this eventually then becomes 15 minus 8 is equals to 7. When you have A4, which is your A3, arithmetic mean 3. So this is 15 plus 3 minus 4, 2. So this will be minus 12 or minus 12. So this is going to be 3. A5 is A4, and that is going to be 15 plus 4 minus 4, and this will be 15 minus 16 minus 1. A6 is going to be A5. That will be 15 plus 5 into minus 4, so that is minus 20. So this is minus 5. And your last one, A7, is equal to A6. And this will be 15 plus 6 into, no, 6 into minus 4 is minus 24, and 15 minus 24 is minus 1. Okay, so therefore, let's start the AP is 15. Your first A1 was 11. Okay, then you have 7, 3, minus 1, minus 5, minus 9, minus 4. Okay, and you can see that, the common difference that you have, it's minus 4 throughout. So let's take another sum. The sum of one term of GP is 315. The first term is 5, and the following ratio is 2. What is the last term? Okay, over here you can see that we have been given the sum of the GP, and we've been also given the first term and the common ratio values. So first we need to find what is n. Okay, once you know n, you can find the last term. So your formula for series. Okay, so your Sn, okay, considering your R is say greater than 1. Okay, so this is the case that we are considering. So this will be A Rn minus 1 upon R minus 1. Okay, so this eventually gives you 315 is equals to Ra is 5, 2 raised to n minus 1, now equals to minus 1. So we get this out. Okay, of this as 315, okay, is equals to 5 to n minus 1. So this is 5. If you get it over here, you have 63 equals to 2n minus 1. And therefore, 2n is equals to 64. Now we know 64 is, the answer when you have something, uh, some power of index of 2. So this is actually in 2 raised to 6 is actually, if you can use 64. And therefore, n is equals to 6. Okay, so we found the n. Now our last term, okay, will be a n is equals to a r raised to n minus 1. So our a is 6 is going to be a is 5 multiplied by our r is 2, and this will be 6 minus 1. So 2 raised to 5. So this is 5 into 2 raised to 5 is 32. And this will eventually give you 1. Okay. Let's take another question. Next, the kth term of an arithmetic progression is q, and the qth term is p. What will be the arith term? So over here, you can see that we are saying that the pth term is q and qth term is p. You can first find out the relation or the expression for the pth term and the qth term. So if you write it as TP, okay, so this is the pth term. This you can write in terms of A plus, and we are saying P, so in place of N, we have P. So this will be P minus 1 D is equals to Q. Okay, so since this is an AP, this is the formula that we will use. And your TQ similarly is going to be A plus Q minus 1 equals to P. Okay, let's call this A and let's call this equation B. Okay, so now over here we can see that D is common. So we can find out your D first. So from A and B, we get D is equals to minus of P minus Q by P minus Q is equals to minus 1. Okay. So therefore, we can, now you can find the A. Okay, since we have the value for D, you can substitute your D value in any of the equations to find our A. Okay, so putting D value in A, you will get 2. So if you put this, your A is eventually going to become 3 plus 2 minus 1. Okay, this is our A. Now, for TR, okay, TR is our R sum, so TR can be written as A plus R minus 1B. Okay, suppose this is what we have. So then you can just add your, so we have our A. Okay, A we have got P plus Q minus 1, and D we have got as minus 1. So A you can just write as P plus Q minus 1, R minus 1 multiplied by minus 1. Okay, and this then eventually becomes P plus Q now plus 1 here. Yes, this will be minus R. Okay, so plus 1. For this, and this gets constant, and what one is P plus Q minus R. So this is your R term expression. Okay, yes, one of the water. Okay, so the next question we have is find the sum of integers between 1 and 100, which are divisible by 2 or 5. Okay, so in this, you have to find all the numbers that are that are divisible by either 2 or 5. Okay, so in a way there will be a few numbers which will be divisible by both 2 and 5, so we will not be considering those. Okay, so we will then what we need to get is the sum of integers divisible by 2 or 5 is equals to, so it will be the sum of integers divisible by 2. Okay, and the total sum, okay, we have to find, and sum of integers divisible by 5 and minus the sum of the integers which are divisible by both 2 and 5. Okay, because we do not want those. We only want either 2 or 5. The sum of integers integers divisible by 2 and 5. Okay. So then this actually becomes which are the integers that will be divisible by 2. So if you uh, see, it will be starting with 2, 4, 12, 6, 8, all the way up to the last term before, the last term that will be divisible by 2 is going to be 100. And now we have to take the sum of the integers that are divisible by 5. So it will start with 5, then 10 plus 15 plus all the way up to 100. Okay. Now we will see which are the integers. Okay, sum of which integers is actually going to be numbers which are divisible by both 2 and 5. Okay, so that would be your 10 plus 10 plus 20 plus 30 all the way up to 100. Okay, so this is what we have. Now, if you see that, between 1 to 100, okay, so you entirely have 100 terms, and half of them are odd numbers and half of them will be your even numbers. Okay, so all the even numbers are actually divisible by 2. So that is, you have total 50 numbers which are which can be divided, which are divisible by 2. So you can convert this sum, okay, with taking your n is equals to 50, because there are only 50 numbers, okay, between 1 to 100 which will be divisible by 2. So you can write this as 50 by 2. You have your, now this is arithmetic progression, okay, all of these are arithmetic progression in nature. So we will get the we will use the sum formula for the arithmetic progression. So over here, your first term is going to be 2. So your, the formula that we have for AP is n by 2. So you have 2a plus n minus 1 b. Okay, so this is the formula. So here we know our a is 2, so 2 into 2 plus our n we have seen as 50. So 50 minus 1, and our d is actually 2. Here. And the next one we can write. Okay. So this will actually be 20. 20 by 2. So you can have this as, now your first term is 5. So 2 into 5, and we have plus 20 minus 1 multiplied by the d over here is 5. Okay. And then you have minus, you have 10 numbers, okay, which are actually divisible by both 2 and 5. So that will be 10 by 2. So you will have your first digit is 10, so 2 into 10 plus your n is 10 minus 1. Okay, and d is also 10. So if you actually, solve these, you can get 1 to a cancel 4, 4 plus 49, 49 multiplied by 1. So this actually comes to 550. The next one is 1050, and the last one becomes 5. then 44, 15. So this is 5, this will be minus. Sorry. This is minus and this will be 550. So if you evaluate this, the final sum, okay, is going to be 350, sorry, 3050. Okay, so this is your final answer, and this is going to be the sum, okay, the sum of series divisible by 2 or 5. Okay, so this is how we can solve such sums. Let's take another example. Okay, so our question, quick. So our question is, if the MSA M term of the series 63 plus 65 plus 67 plus 69 plus so on, and 3 plus 10 plus 17 plus 24 plus are equal, then find the value of them. Okay, so this is the question. So there are two different series, okay, and we are saying that one of the term, the mth term for in both the series are actually equal. So we have to find the what is the value of the m. Okay, so let's just both of them. If you see carefully, both of them actually form an arithmetic progression. Okay, so for the first series, it will be the d is 2 and the next one is 7. Okay, now that's fine. Okay, so series 1 is going to be 63 plus 65 plus 67 plus 69. Okay, all the way. And in between, you will have one T M. Okay, and then so on again. TM1. Okay, let's write it as TM1. Now you will have series 2. So over here you have 3 plus 10 plus 17 plus 24. All the way up to some term TM and then continue on. Okay, so we have been given that TM1 is equals to TM2. Okay, well, let's find TM1. So T, this is your okay. So TM1, okay, we can get it as yeah, 63 plus, you can see the D is equals to 2 here. Okay, and over here, your D is equals to 7. Okay, so those actually then become 63 and M is our M. Okay, suppose M, we are just making it T1. Okay, we are not considering the N part as M1. Okay, so M is going to be our N. M minus 1, our D is 2. So this will be 2M and this is minus 2, 63 minus 2. is plus 51. Okay, and similarly, TM2 is going to be 3 plus you have m minus 1, 7, so this is 7m, what is minus 7, minus 7 and 3, so you have minus 4. Okay, now as per our given, okay, Tm1 is equals to Tm2. So our Tm1 was 2m plus 61 is going to be equal to 7m minus 4. Okay, so now you can get this as 9m is equals to, sorry, not 9m, 5m is equals to 55. Okay, and therefore your m is equals to 13. So we can say that the 13th term of the first series is actually equal to the 13th term of the second series also. Okay, so this is what we know. So if you want to know what is the actual term, okay, so suppose you put, so m as 13 over here. Okay, so suppose that tm1 then actually is, okay, so now it won't remain tm1, it is going to be remaining as tm because the tm in both the series are the same. So this is going to be 2 multiplied by 13 plus 51. So this will be 26, 26, 87. Okay, so this is what we get. If you are also asked to find the term, okay, so that we are trying to solve for. Let's take another example. The first female term of a geometric progression of x, y, and z. Okay, such that x plus y plus z is equals to 42. Okay, the if the middle term y is multiplied by 5 by 4, then the number x 5 by 4 y and z now on an AP. Okay, so first it was a geometric progression. Now we are considering the changed, the changed terms to be forming an AP. Okay, so we have to find the largest value possible for x. Okay, so we have to find the largest possible value. Okay, sorry. So suppose you consider your for the term, okay, x, y, z are in geometric progression. Okay, we also know that, for a geometric progression, you have ar squared, ar cube, okay, and so on as a geometric progression. So similarly, we can write x, y, z in the form of, the geometric progression term. So you can write x is equals to say x, and y actually then becomes x r squared, sorry, x r, and your z is actually x r squared. Now we know that the sum of these three is actually 42. So therefore, this actually then you can write as x plus xr plus xr squared is equals to 42. Okay. Now we know that the middle term is when it is, uh, multiplied by 5 by 4, it becomes an 8. Okay. So therefore, you can then write that given we are considering, 5 by 4y can actually then be written as 5 by 4 xr. Okay. Now we can see that the common difference d, okay, between, so that x 5 by 4 xr and xr squared are now 180. Okay. They are an arithmetic progression now. So therefore, we can write this as 5 by 4 x r minus x will be equal to x r squared minus 5 by r x r. Okay, so the common difference between the second and the first number and the common difference between third and the second number will be equal. So that is what we have, noted over here. And so now you can, convert this into actually quadratic equation, okay, so that we can solve for our r, okay, and then eventually we can get our x. For this, you can then write it as 2 or 5 minus 5r plus 2 is equal to 0. So if we solve the equation, okay, then you can get a quadratic equation, okay, or an equation in terms of your r. So this actually then gives you r is equals to half or r is equals to 2. Okay. So now if you substitute your values of r in the first, equation, okay, where you have x plus xr plus xr squared is equals to 42, you can get your answer as x is equals to 6 or x is equals to 24. Okay, and this is the answer because we have to find the largest value possible for x. Okay, let's take the other example. Find the middle term of the sequence formed by all. Let's wait a moment. Okay. So we have to find the middle term of the sequence formed by all three-digit numbers that leave a remainder of 5 when divided by 7. Okay. So this is we have to find the middle term of the sequence of the three-digit numbers, which when divided by 7 leave a remainder of 5, and we will also find also find the sum of all terms on either side of the middle term separately. Okay, so this is what we are asked. So the three-digit numbers. Okay, so after 100, whichever numbers are in such a way that when divided by 7, they will give you a remainder of 5. Now, also remember that the consecutive numbers will actually eventually end up having a common difference of 7. Okay, so you can write this as the list of three-digit numbers that leave a remainder of 5 when divided by 7 is okay. So the first number, if you write the first number itself, then you can, actually go on writing all the other numbers. So the first number is actually 103. Okay, so if you divide it by say 7, okay, so we have 7, 1, 2, 33, 33, so 4, 28. So 33 minus 28 will give you 5. Okay, so this is the first number. Now you have to keep adding 7 to this. Okay, you will get the next number. So 110, so this is 117, and all the way up to actually triple nine. So therefore, our A it becomes 103 and B is equals to 7. Okay, and then we have to find our N. So you know that your AN is equals to A plus N minus 1B. And over here, we know that the last term over here is triple nine. So we can just write it out. So this is what we have. Therefore, you can write that 999 is equals to our first term was 103. Okay, so 103 plus. So now you have your N minus 1. So common difference is 7. So that is again, so what we written it. That is equals to 999. So now we'll solve for it. So this will actually then become 999 is equals to 153 plus 7n minus 7. So when you have 7n plus 96 equals to 999. So 7n is actually equals to 903. Okay, and you will get n as 7 divided by 1, 0, 2, 14, 64. Okay, so n becomes 129. Okay, so now when we have, say, uh, odd n, okay, when you have odd total number of terms, so you will have one middle term. Okay, so you will have a middle term and you will have equal number of terms on the left and the right side of this middle term. Okay, so this is the understanding. So how do we find what is the n, or which term is actually the middle term? So therefore, for odd number of terms, okay, there is only one middle term. If you have, say, an even, number of terms, so that in that case, we will actually have two middle terms. Okay, so we will have two middle terms in that. So therefore, the T mid is actually, it actually corresponds to your n plus 1 by 2 term. Okay, so half of your n plus 1. So over here we have n is 129, so therefore n plus 1 by 2 is actually 130 by 2 is 65. Okay, so your 65th term is actually the middle term. Just add a right. So this, therefore, the 65th term is A plus 64D. Okay, 65 minus 1. So this is going to be A is 103. Plus 64 into 7 into 5. 1. Okay, so this is our 65th term. Okay, so the middle term. Now we want to find what is the sum of the first n terms, okay, of the AP. So we will see up to the 64th term. Okay, so because 65th term is the middle term, so up to 64th term we will find the sum of those. Okay, so therefore sum of first 64th term will be, so we will use the formula of Sn is equals to n by 2 and in bracket 2a plus n minus 1d. So our n over here is 64. So 64 by 2. Now you have 2a. So our a is 103 and we have 63 multiplied by 7. Okay, so you have n minus 1d. So this is what we have. And this actually eventually comes out to being 20704. Okay, now we'll find the sum of terms after the middle term. Okay, Now we know that our n we had got, okay, sorry, we have not got our n. So we had our n, okay, so n is equals to 129. So now what you can, actually get is you can get all the sum, okay, sum of all the terms, so that is up to 129, and you can then, subtract the sum of the 64 terms, so you can get the sum of the remaining terms that we have. Okay, so this will be S. So over here I use directly with the n value. So S64. Now we will find S129. So that is 129 by 2, and then multiplied by 2 into 103 plus, now you have n minus 1d, so this is 128 multiplied by 7, and this eventually actually gives you 7107 Okay, so therefore, sum of terms after middle term will be your S129, okay, minus your sum of the first 64 terms as well as the middle term itself. Okay, so this then becomes 71079 minus your S64 is 20704 plus you have 551, and then this actually becomes 49824. Okay, so these were some of the examples of how you can solve sums related to sequences and series. So it's easy. You only have to remember the formulae. Okay, and in some cases you might have to convert the statements into simplified expressions so that you can solve it easily. Okay, so we will stop here for today. So this will be the last class for sequential theory. So thank you so much for attending. Hope this helps you.